Hello and welcome to Making Games in C, and we're going to have another go at making a text adventure game, just using the C language and the command line. So to begin with, we're going to set up our project settings. So we'll just open up our documents and we'll create just a new folder. We'll call it new, we'll just call it text adventure. Okay, and then we'll go into that and then we'll open up our text editor into this folder. So we'll go File, Open Folder, and then we'll select it in here. So text editor, text adventure, select folder, here we go. Okay, so we've got that all set up now, and now we'll create our first file. So we'll call it main.c. Okay, so we're going pretty good so far. So we've got our main.c file where we'll put our entry point into our program. And the next thing we're going to do is make sure we've got a compiler to compile it. So if you haven't downloaded Visual Studio, download that off the internet. And once that's done, you'll be able to access the compiler from the command line. So we'll open up the command line, and if you can't find it, we can go command prompt, and it'll be in your start folder. Okay, so we've got it here, and we'll just go into documents. So cd ... to get back one, cd ... to get into documents. If we list what's in there with dir, we'll see that we've got our text adventure folder. So we'll cd into text adventure tab to auto complete. Okay, let's see what's in there. So we've got our main.c file. And so to run the compiler, the Visual Studio compiler from the command line, use the cl command, but you'll see cl is not recognized. And that's because in order to set that up, we have to run a build a startup script to basically allow us to access that. And it's a little bit different on all different platforms, but mainly the same. And I'll post where you can look for the different commands to call. So I'll just find the one we'll be using in here, source. So we'll just have a look in here. Oh. So basically this is what we have to call. We basically want to call this bat file, which is in this folder. And so I'm just going to copy that line of code, and don't worry, I'll put a link to it in the YouTube comments to be able to go there. So I'll just Control V that. Okay, we're starting up, and you'll see it's loading. Okay, it's all set up now. When I try CL again, you'll see, yep, it knows that that's the C compiler, Microsoft C compiler. Okay, so we'll keep this folder around just for now, but we'll stick with our main. So if we go cl main.c file, see it Painter is giving us a link error saying entry point must be defined. And so all programs have a main function to actually start. This is where they start in the program. And the one for command line programs goes like this. So it returns an int. It's called main. The arguments are, it has a char, double star, arg count, and an int. These are actually the arguments, and this is the argument count. So this is just a shorthand saying, hey, we're passing in some string arguments, which is an array of strings. So we've got a double pointer to a char type and number of ints. So this is basically when we go into the command line and we try to run it. Say our program's called main.exe. We could pass different arguments to it, like we could say like, hey, and maybe there's some parameters. So we want to say, like, say if we were running a game, we would specify maybe we want to run the window to be 1920 by 1080. So this is just some examples of what we could pass in here, but we actually aren't using them. This is just what you have to type in order to get a program up and running if it's from the command line. And then we're just going to return 0. So basically, the main function wants to return an int, so we have to actually do that and return our promise that, hey, we're returning an int from here. So we'll save that and we'll go back to the command line. We'll type in cl again and main.c. Oh, yep. And where did it actually put those? We'll have to find out. So let's just stir. So you can see here it's got it outputted them into the folder we're in. So it's outputted a main.exe and a main.obj file. So the one we're interested in is the main.exe file. So if we now run that using /main autocomplete to exe, so it would have run it, we're not doing anything, so it just goes, okay, come in, oh, and return, finished. So we could try now do a printf, and let's just say hello world, save that, we'll compile it again using the up arrow to look for previous commands. Okay, compile it, and we'll run it again, just look for, there it is, and it ran, it gave us hello world. Awesome. So we're on the right track here to make our text adventure game. So let's just get started and let's say hello adventurer. What is your name? Okay, and we'll compile that. So I'm just using that up arrow to make it short and sweet, and run it. Hello adventurer, what is your name? And I think I've spelled that wrong. Adventurer, or maybe I did. Okay, the next thing we actually want to get input from the user. So I believe it's scanf in C we can use to actually, the command prompt will wait for the user to actually type in what their response is. So we'll just look that up on the internet and look how you call it. So scanf. So color decoration. So it's format. This is the C string that changed one more. So basically, we can specify the maximum number of characters to be read. Specifies a size from the int. So this is what we're looking for. So we'll see an example. So they're saying printf enter name, scanf, and put it into this array. Okay, so we'll just put in our format string. So we're asking for a string back. So we're saying, hey, this string is going to be an S. So type string. This is the here you can see we're doing a printf, and we're saying wherever you see this %s, now replace it with the first parameter. And so if we do %s again, we could do what are you doing, and you'll see it will come up again. So we'll just compile it. Oh, we'll actually comment this out just for a moment. We'll compile it, no errors, and we'll run it. Hello adventurer, what is your name? What are you doing? And you might want to put a new line under there just to give it some spacing, or we'll actually just delete for now and we'll get our scanf going. So we've got our scanf and we're going to stick it into this array. So we're going to say char, so an array, so this is our name, we're just calling the variable name, it's an array. In C you specify after the variable name, not in the type parameter. So and we'll say this is just length of 256 characters. We're not initializing it, name, and then we'll print the name again. So we'll use the same format string. We can just go name, and that should actually work as well. So we'll compile it. Oop, doesn't need a semicolon there. Compile it. Oop. So we've got unresolved scanf reference. So you can't find scanf. This is because it's in an actual library we have to tell. It's in the standard C library, but we need to include the header file to allow us to actually reference them. So we'll go and I think it is in STO standard IO, so input output.h. Try again, and didn't get any errors, so now we'll run it. So you can see now it didn't exit the program straight away, it's just waiting for us here on the command line to enter something. So my name is Oliver, and then it output my name. So we'll do something here, so we'll do our format stringing again. We'll say y hello, and then it'll put the name in, so it'll go to the first variable we're passing in, and we'll replace this with that variable. How are you? And we'll run our build script again, cl main.c, and we'll compile it. My name's Oliver. Hello Oliver, how are you? So it's replaced this %s with our first variable name. Okay, we're off to a good start. The next part is we're actually going to create a game loop, so we don't exit out of our program. We kind of stay in this infinite loop until we decide we want to exit it. So like we could write our whole game and we could just like have all these kind of just every single thing we want to do just be all in a line, kind of progress downwards. But this is messy, and it doesn't actually allow for like interesting things to occur because we've kind of already pre-programmed every possibility into the program. So instead, we're going to do a while loop. So we're doing while, and we're going to stick everything in here, and we're going to say we're going to call a boolean, and short in Java you say boolean, but in C++ you say bool, and you'll find out that C doesn't have bool, so we'll have to define that ourselves. So we'll say game is running, and we'll say true. Okay, and while game is running, we'll keep asking till actually we'll actually say go straight into a text adventure, and we'll say what do you do? Okay, that's good. And the person will input their response, and when it gets to this, it will go straight back up, check, hey, game is still running. Okay, we'll ask him again, what do you do? So we'll rename this to response just to clarify that. Response, and we'll just say your response was %s response. Okay, we're off to a good start, and now we'll compile it. So it's saying bool is undeclared identifier. So in C, you can include st. I don't know if this is right. Okay. There is a library we can include, but we can also use C's typedef parameter. So we can say we'll just say we want to we're just going to reference an int. So when it's 0 it's false, when it's 1 it's true. So we can just so true 1 0, and I think I've got them around the wrong way, so let's see. So we'll just swap these around, and these actually might, let's see, so these actually have to be define true as 1, define false as 0. And so it doesn't like this one. So int followed by int is illegal. Where is this? 7. So it does not. I'm not sure if these are defined. I actually forget how you do this, but we'll just go C include bool. std_ball. Did I try that one? std_ball.h. Yay, it worked. So to get the Boolean type, we can just include this std_ball. So from the standard library, include the Boolean module or header file, so we can reference actual this type from it and true and false. And so we can do now while game is running, and we'll actually run it, and we should just stay in this infinite loop forever. So what do you do? There's a yeah. What do you do? So the response was yay. We missed a new line, so we'll put a new line there, but then it asks us again, so we can just so we'll just stay in this infinite loop forever, and we'll get out of that. So I think Control C is exit out of it. We'll clear it with CLS. So now we actually don't want to stay in that forever, but we want to actually see what the response was and do stuff with it. So here we go. So we want to, first of all, we'll say, hey, you typed in Q or you typed in quit. We want to just quit the game. So we're going to go if response, the first character in this array is equal to the character Q. We're going to say running game is false, else actually run the game here. And we can also do else if response, and we'll try string, we'll say is equal to this string, but in C you can't do this, you have to actually do it. We have to actually run our a string of pair or string match, and we'll write that function ourselves. So we'll say my string, or we'll just call it string match, pass in response, pass in the quit value, and we'll return a boolean. Hey, if the response match quit, we're going to do the same thing. So we can stick it in the same array there. Actually, we won't do that just for ease. At least we're about to do something else. So we'll say is false again. But say if their response was actually like quilt, and that's actually part of the game, we don't want quit. So we actually want to see, hey, did you actually pass anything else after this? So, and the next character is the null terminating string, because in C, strings are not defined by their length, but basically defined when you hit a this null terminating sequence character. So this is part of the ASCII character set, and it basically means, hey, this is a null terminating character, and it has different meanings in different contexts. So basically say, hey, if it was Q and that was the only character in the response, you meant to say you quit. So let's see if this runs, and we put a new line there. So we'll build it again. CL main. Oop. So it's unresolved externals. String match. Oh, we haven't actually made our function. Okay, so let's make our first function. So we'll write, it's going to return a boolean, be called string match. This is what's inside it, and coming in, string A and string B. Okay, now we need to see if they are equal. So here we go. So bool result equals false. So we'll just start with, hey, they're not equal, and we'll return what our result was. So we're returning a boolean type, which is the same type as the return type. Okay. So now we're going to go while string A, so we'll dereference the pointer to actually get the character out. So character pointer is saying that we're pointing to an array of this type, or we're pointing to some place in memory that has a char in it. And in C, strings are just big arrays of characters. So it'd be like if each of these is a byte in memory, the first character is H, and then we move one byte along, and next one's E, move one byte along, next one's L. So our pointer is pointing to this first H, the start of it, and we just basically walk this until we reach a byte that looks like this, the null terminating character, meaning, hey, this is the end of the string. So we're going to do that, so it doesn't equal the null terminating character, and notice we're using the single quotes to define a character, not a string. So we can't do that, we have to do this. And the other one, string, doesn't equal that, so that null terminating character, so we're dereferencing it, saying actually get this character, what is the value of this, not just the address in the memory. Well, that doesn't equal that, and then we can actually see if they're equal. So string A, dereference it again, equals, and do result equals this. We'll just put these just to make sure it's actually working this one out, which it would. Okay, is string A equals to the character at string A is equal to the character at string B. So keep going until one of these hits the null terminating character. And we also want to, each time we go around the loop, we want to advance each string by 1 byte or 1 character. So in C, since we do +1, it knows pointer arithmetic, so it knows, hey, advance this by whatever type this is. So we move, like our example, H, E, L, L. So like that, we start at this one, and then when we do +1, okay, now point to this place in memory where E is +1, we point to where L is in memory, and we dereference it using the asterisk to actually get this, what this value is in the memory. So we'll make sure we advance the other string like that, and like that. And you'll see, like result is, we'll actually start with result equals true, and we're just going to try break this, whatever this value is. So basically, whenever we basically use an and, we're going to say and equals, so we're going to say result is true, so this always has to be true. If this is false, a true and with a true will be true, a true and with a false will be false. And that means, hey, this doesn't match, just get out of here. We could just do result equals that, and we could do if result is false, just break the loop, so get out of here, you know it's false. So basically we're saying you've got to keep this alive in order to reach here to make sure it's still true. So we go through the whole character set and see if they're equal to each other. But the other catch we have to make sure is, say if the string A is EL, and then it's got the null terminating character. If we then go, if the next one is L, so it's got 1 extra L, when string A comes in, it's going to hit the null terminating character before this one. So it isn't actually going to check, it doesn't know that there's an extra L here because we've just exited out. So basically we want to make sure we got to the null terminating character at the same point in time. So we want to make sure we go if result equals true, so this means we haven't broken early and these should be both at the null terminating sequence. We can do if result equals true, result equals basically check if they're both at the null terminating character. So they're both the same length. So this dereference is equal to null terminating character. Oh. And string B is equal to that. Okay, if it's not, they weren't the same length, and so this will be false and will turn false. Just keep that for now, and we'll compile it, see if we've got any errors. Oop. We've got an error on line 28. Oh, we get that, so we'll delete that. Okay, now we'll run it. We'll say, see if we can actually, if this works. Response was quit, and it quit. Yay! So that's great. And we'll actually run out and see if we can, do this case where we actually add one character. So it's checking string A will be quit because, string B will be quit because we've set it here as quit. So it'll look like this. And the next string, what we pass in, we'll say it's going to be the same as the string B, but we're just going to put an extra sneaky character on the end, quit, and see if our string match routine handles that. So what do? We're going to say quit, So it recognized that it wasn't equal to quit, and we came back around and went in our loop. So that's looking pretty nice. Let's see if our string routine can actually handle if we don't pass any strings. See if it crashes. Oop. So maybe scanf needs a natural response. So we'll do Q to see if that works. Yep, exited out. So we'll basically have to do a bit more safety around this scanf function, because you notice we're passing in a 256 size array of char, but what happens when what if the person types in more than 256 characters? We're going to memory overflow, array overflow, we're going to write on memory, memory corruption, bad news. So say if we're only looking at one character, let's say 2 characters, in order to store the null terminator in there as well, because scanf automatically will put a null terminator in. So basically, let's put more than 2 characters and see if our program crashes. So we'll compile, run it. Okay, here we go. We're going to say ASD. So we definitely passed 2 characters. The response was ASD. So we're not actually sure. It might actually have run over that memory, and this just hasn't appeared yet, like problem-wise, because no one else is using it. But we definitely want to handle that case, because we're good programmers, we're not bad programmers. Okay, we'll leave it here for today. So we've got a good start. We put in our string match function. We included the standard stdio in order to use printf and scanf function. We put in stdbool to use Boolean types, which aren't available normally in C. We wrote our string match function that handles these different cases. We wrote our entry point to our program, and we also ran our game loop. I wrote our game loop for our actual game, which appears in basically every single software would have this some sort of infinite loop that just keeps running until it's requested to not stay in there. And then we've got our actual main game logic going through here, and then checking for quit responses. So we'll just comment this. So check for quit responses, and we'll say, so this will be like ask player for option, and then check for quit responses, and then here we'll like handle input responses. So we're actually going to start doing some stuff with what the player says. Okay, and this is our game loop. Okay, so we'll save that, and so next episode we'll keep going with this. So thanks for watching and see you in the next episode.